Jumping off in question 5, we've been given two functions, f of x, which is a parabola, and that's the sad face over here, and g of x, which is an exponential function. Anything to the power of x forms like a ramp like this, an exponential function. So I'm going to color code these guys quickly. Yeah, it's much better. Alright, so like look what a difference that makes. I also like to write the equations nearby so that I have them on hand and I don't have to keep going back up to this. Okay, now we need the length of AC first of all. We've got A and C over there, they are very special points. So A and C are x-intercepts. They where the blue graph cuts the x-axis. And to get x-intercepts, I make y equals 0 and solve for x. And then just remember f of x is a fancy placeholder for y. So I'm just going to change this y to 0 and then solve for x. Alright, don't fall in the trap. The square means you write the bracket twice and FOIL. And then just remember to keep this negative in front, and now we're going to go ahead and FOIL those brackets. And then after we FOILed, we're going to distribute this negative inside the bracket. And then we've got a couple of like terms here that we're going to sort out. Minus 4 plus 9 will just give you plus 5. And now I can't factorize this thing just yet. This negative is bothering me. So I'm going to divide everything by -1. So essentially everything's sign will change. This will change to a positive, this will change to a negative, and this will change to a negative. Okay, now that that negative is gone, we can start factorizing the trinomial. So I look at the factors of 5. Oh my goodness, it's a prime number. What a dream. So it only has two factors, 1 and 5. So I've somehow got to add or subtract those to get this -4 in the middle. And I can accomplish that by saying +1 minus 5. And those will form my two brackets, x plus 1 and x minus 5. And from there, my two answers for x are these numbers with the opposite sign. So x equals -1 and x equals +5. After we got those, we've got to decide who belongs to who. So because a will have a negative x value, because it's on the left of the y-axis, that has to be the negative x. So a is -1, which will make c +5. Okay, so we're getting to know the blue graph a little bit better. And to get the length of a horizontal line, you can use the distance formula, but there is an easier way that will be very worth your time to get used to. So you just take the x value on the left minus the x value on the right. Sorry, that's my bad. The one on the right minus the one on the left. So right minus left. Try and get used to that. Okay, so the name of our particular horizontal line is AC. So I'm going to change the name here to AC. The x value on the right is 5. And the x value on the left is -1. And then a minus and a minus give you a plus. So 5 plus 1 will be 6. And then just make sure to slap the word units onto that. And lastly, let's have a look where our 4 marks are coming from. First mark comes from making y equal to 0 to get x-intercepts. Second mark comes from your standard form. Third mark comes from the correct x values. And the last mark comes from the correct answer of 6 units. Next up, we need to determine the value of b. B is sitting snug in the equation of the red graph. So to get the value of b, I need a point on the red graph. So to get that is going to be quite tricky. You must just be careful. A is not on the red graph. The red graph is slightly above A over there. So we're going to have to get this point here, D. And I use that by looking at the blue graph. Now, I don't know if you've noticed, but this is in a very special format. It's in the turning point format of the parabola. And if it's in that format, I can extract quite a lot of things. I can get the x value of the turning point there and the y value of the turning point at the end over there. So I know that D is the turning point of the parabola because they did tell that to us in the question. D is the turning point of f, the parabola. So I can literally write down this turning point. It's 2 and 9. And now that I've got a point on the red graph, I can just sub that into this thing and solve for b. So I'm going to grab this equation. Remember, g of x is a fancy placeholder for y. And then your first coordinate, well, the first number in the coordinates is the x value. The second number is the y value. So this 9 will go into y's place, and this 2 will go into x's place. After we made that substitution, we need to get rid of the square by square rooting both sides. And the square root of 9 is just 3, so b equals 3. And then your 2 marks over here just come from subbing in the right point, as well as your answer for b. And then once I get this answer for b, I'm going to fill it in over there so that I know more about the red graph. Okay, and then the next question says determine the values of x for which g of x, the red graph, is greater than 9. Right, remember g of x is a fancy placeholder for y. So it's asking you where is the y value of g of x bigger than 9. And so what I do with these questions is I draw a horizontal line through the y value of 9. And now it wants to know where this function is above that line. So it starts here and then it goes on forever that way. So this is where you start and you go to infinity. So there's two ways I can represent this answer. The first way is I can say whenever x is bigger than 2, this inequality occurs. And it will also equal 2 because we've got the inclusive symbol over there, the inclusive inequality symbol. Or what I can do is I can write it in interval notation. So I can say x is an element that starts at 2 and ends at infinity. And then I will have to use a square bracket over the 2 because I've got the inclusive symbol there. The square bracket means it does include 2. And then infinities always get round brackets. So it's really up to you. You must write this or this. Do not write both. Just use the one that makes more sense to you. And the 1 mark just solely comes from the right answer. So it's all or nothing with this question. 5.1.4 asks us to write down the equation of h of x, a new function, if h of x is the equivalent of f of x plus 2 minus 9. Right, so I'm going to start by writing this down. Now we have f of x's formula over here. Now what this is telling us to do is it's telling you replace your x's with x plus 2. So what you do is you just grab this equation here. I like to put it in a square bracket because there's going to be a minus 9 on the outside there. And you see this x here? I'm going to replace it with x plus 2. And then that minus 9 will just chill on the outside. And now I'm going to go on a bit of a mission to simplify this thing. Okay, so plus 2 minus 2, they actually cancel each other out. So I'm just left with a minus x squared over there. There's not even a use for these square brackets, so I'm going to get rid of them. I only had them there to illustrate what was being changed. And then on the outside, plus 9 minus 9, they cancel each other out. So here's h of x. And our 2 marks come from the necessary substitution of replacing this x with x plus 2, as well as gluing on that minus 9 at the end, as the question instructed us to. And the second mark just comes from the answer. 5.1.5 asks us, how can we restrict the domain of h of x? This is h of x. None of these graphs are h of f. This is f and g. So we're looking over here. Restricted so that the inverse of h will be a function. So what this graph looks like is it's a sad face that goes through the origin. So h of x will look something like this. And what I essentially want to do is I want to chop off half of it. So I want to get rid of this half, or I can get rid of this half. The norm is to get rid of the negative half. Everyone just does that. So to do that, what I need to do is this. So to chop off that half, I need to say x must only be bigger than or equal to 0. It can't be anything smaller than 0. Bear in mind, you can have a different notation. The other notation is also accepted. So the other notation will look like x starts at 0 and then goes on for infinity. So you can use either or. This is the one that's most widely used, but you can use either or. And why we do that is so that the inverse will be a function. So the inverse will look like this. If I did not restrict the domain, then the inverse would have looked like this. And that is not a function because it fails the vertical line test. Okay, I went down the rabbit hole a little bit there. Okay, the 1 mark purely comes from your answer over here. Okay, now I need to show algebraically that this is equal to that weird thing. Okay, if I'm asked to show, I'm only allowed to work with one side of the equation. So I'm going to maybe choose this side of the equation to work with. So let's grab that and make the necessary substitution. So what I've done is g of x, I've replaced the x with x plus half. So this x here, I replace it with x plus a half. And now we've got to kind of manipulate this thing to make it look like this thing. So I'm going to use an exponent law to split this up. And it's law 1 of exponents. So law 1 of exponents states if you have the same base and you're multiplying, you add the exponents. But I'm going to do this in reverse. I've got this side and I'm going to split it up into this side. So how you can notice how I've split that up. 3 to the power of x times 3 to the power of half. Now 3 to the power of a half, we can use an exponent law, or we can just use our calculator to change that. So I'm going to use exponent laws to change this. The specific exponent law means we've got to convert this to a surd or a root. And this is how that law works. If I've got something raised to a fraction as an exponent, then this one goes under the root. This one goes outside the root, or if you're going this way, this one goes at the top of the fraction. Sorry, made a slight mistake there. This one goes to the bottom of the fraction, and this one will go to the top of the fraction. So over here, I can convert this into a surd by doing this. And 3 to the power of 1 is just 3. And I don't need this 2 here. If I have a square root, it's implied that there's a 2 there, so I can get rid of this 2. And now I've essentially almost proved what they've asked me to do. The root 3, I've got the root 3 over there, and then this is g of x, so I can just change this to g of x. And then my job is done. So let's have a look where the marks are coming from. So the 2 marks come from the correct substitution as well as the correct use of exponent laws.